Hello and welcome students. This is a new lecture on vectors. In this we are going to solve few problems from exercise 5.3. Question number 5 is, suppose that all sides of a quadrilateral are equal in length and opposite sides are parallel. Use vector method to show that the diagonals are perpendicular. So here I have drawn, so my answer starts from here. So in answer, first of all, I will draw a quadrilateral, and in this quadrilateral, as you see that we have, in this quadrilateral, we have four sides which are equal in length. These four sides are equal in length, and the opposite sides of the quadrilateral ABCD are parallel to each other. So AB is parallel to DC, AD is parallel to BC. We have to prove that the diagonals of this quadrilateral are perpendicular to each other. That is, we have to show that AC is perpendicular to DB. So here I start by writing referring to adjacent quadrilateral ABCD. Now here I write AB is equal to BC equals to CD equals to AD. So therefore, I will write here magnitude of AB bar equals to magnitude of BC bar equals to magnitude of CD bar equals to magnitude of AD bar. Since all the sides are equal, so if I consider them as vectors, what I will notice that these vectors will have equal magnitude. These vectors will have equal magnitude. Okay. Now, further, I have the sides parallel to each other. I have the sides, opposite sides parallel to each other. So I will write AB bar is equal to BC bar. This is, I write this one as 1. This is 2. AB bar is equal to BC bar, and I write BC bar is equal to AD bar. BC bar is equal to AD bar. Now why I could write this? Because see, AB bar and DC bar, they are having same magnitude and the same direction. They have equal magnitude because they are equal in length and they are parallel to each other. So AB bar and DC bar, they are in same direction. So these two vectors are equal, same as BC bar is equal to AD bar. Further, I write that to prove that AC bar is perpendicular to AC bar is perpendicular to DB bar. DB bar. That is to prove that AC bar dot DB bar is equal to 0. As you know, students, if the dot product of two vectors I am getting equal to 0, if the dot product of two vectors is equal to 0, then the two vectors are perpendicular to each other. So what is my aim here? My aim is to prove that AC bar dot DB bar is equal to 0. This is my aim. Okay, this is my aim here. So first of all, what I will do is I'll find out AC bar. See, AC bar. I write here AC bar is equal to, now see, in triangle ABC, I will apply the triangle law of vector addition. I will apply the triangle law of vector addition. So here I see AC bar. Look at this AC bar. This is vector AC bar from A to C. From A to C. Now what I notice, A to C is A to B, then A to B, this vector, plus B to C. So I can say AC bar is equal to AB bar plus BC bar. Okay, this is by triangle law of vector addition in triangle ABC. So AC bar here is equal to AB bar plus BC bar. This is equation number 4. Then I go for DB bar. I go for DB bar. This is, I can write in bracket here. I can write in bracket here by triangle law of vector addition in triangle ABC. This is my explanation for equation number 4, how I got equation number 4. Then I go for DB bar. Okay, see students, you want AC bar and DB bar. So I have found AC bar, now I am going for DB bar. DB bar is, I will write DB bar is this vector D to B, right? So DB bar is DA bar, DB bar, this vector is, I will have here DA bar plus AB bar, DA bar plus AB bar. D to A, then A to B is same as D to B. So I will get here DB bar is DA bar plus AB bar. This is number 5. And the explanation for this is by triangle law of vector addition in triangle ABD, in triangle ABD. Now I will go for the dot product of AC bar and DB bar. So I write here, therefore AC bar dot DB bar can be written as, see, I will write for AC bar, I will write AB bar plus BC bar. So here AB bar plus BC bar dot, I have DB bar. For DB bar, what I will write, students? I will write here for DB bar, see, this is dot in between them. DB bar is DA bar plus AB bar. Now in the next step, see what I will do. This is on the right hand side, the first bracket is AB bar plus BC bar. I will keep it as it is. In the second bracket, see, I have DA bar. Look at this vector DA bar. DA bar is this vector. DA bar is this vector. DA bar is negative of BC bar. So this vector and this vector, they are equal in magnitude but opposite in direction. So where I have DA bar, I can write minus of BC bar. You understand? If you see equation number 3, in equation number 3, you have BC bar is equal to AD bar. In equation number 3 here, if you check equation number 3, in equation number 3 here, you have BC bar and AD bar equal, but I want DA bar. So DA bar will be negative of BC bar. It will be negative of BC bar. So I write here DA bar. For DA bar, I write minus BC bar plus AB bar. In the next step, see what do I get. So right hand side will become, the left hand side is still the same. That is AC bar dot DB bar. And the right hand side, I have AB bar plus BC bar. AB bar plus BC bar dot, and here what I have minus BC bar plus AB bar. I rearrange this. I write AB bar first and then minus BC bar. So I have here AB bar minus BC bar. Now from here we have to distribute dot over difference. So see this, I will distribute this over the difference. So I have here dot product. What I will do, I will write AB bar plus BC bar dot AB bar, and then AB bar plus BC bar dot BC bar, and in between I will have negative signs. I will have negative signs. So the next step, I will have AB bar plus BC bar dot AB bar minus AB bar plus BC bar dot BC bar. Now the distribution will be from right. The distribution from right. So here we have dot AB bar. It is distributed this way, and here dot BC bar. It is distributed like this. Okay. So we will have AB bar dot AB bar plus BC bar dot AB bar, then minus AB bar dot BC bar, again negative sign because outside the bracket we have negative sign, minus BC bar dot BC bar. Now as you know students, AB bar dot AB bar is mod of AB bar square. Now here what we see is, look at these two. Look at these two. Here you have AB bar plus AB bar dot A. Here you have BC bar dot AB bar. This is BC bar dot AB bar. And this is AB bar dot BC bar. They are equal because in dot product we know A bar dot B bar is same as B bar dot A bar. Okay, dot product is commutative. So these two vectors are same and these two are same. This dot product and this dot product are same and they have negative. They are negative of each other. They have opposite sign. This is positive, this is negative. So what will happen? They will cancel each other. So these two get cancelled. They cancel each other. And the next step you get is AB bar dot AB bar give you mod AB bar square, and here you get negative mod of BC bar square. BC bar dot BC bar is mod BC bar square. Now, we have already written that mod of AB bar, see this, mod of AB bar and mod of BC bar, they are equal. They are equal. Magnitude of AB bar is equal to magnitude of BC bar. So what will happen? Their square will also be equal. So this gets, you see, they are equal to each other. So this will also cancel. I hope you understand. This will also cancel. So the next you get is equal to 0. Equal to 0. So here you get AC bar dot DB bar equals to 0. And this is enough to conclude. This is sufficient to conclude. Therefore, AC bar is perpendicular to AC bar is perpendicular to DB bar. Therefore, the diagonals of quadrilateral ABCD are perpendicular to each other. They are perpendicular to each other. Hence proved. We have proved this. I hope you followed this. You can just go through this once again and write the solution for the practice. Now we have question number 7, which is quite a simple question. It says find the angle P. Now when they say find the angle P, it means the angle at vertex P. Find the angle P of the triangle find the angle P of the triangle whose vertices are P 0, -1, -2, Q 314 and R 571. So what we are given is, students, we are given the vertices of triangle. We are given PQR. So I will make the triangle here PQ and R. So suppose this is the triangle given to us. Okay, it is just a diagram for the reference. So P is here, I write Q and R. PQR are the three vertices given to us. I have to find angle P, that is I have to find the angle at P. I have to find this angle. Okay. So for this, what I will do, I am given the vertices, I am given the coordinates of the vertices 0, -1. The coordinates of P are 0, -1, -2. Q are 3, 1, 4. And coordinates of R are 5, 7, 1. What I will do is I will find out the position vector of these points. Okay. So my solution starts from here. I will write P bar equals to, P bar is 0 I cap minus 1 j cap minus 2 k cap. Q bar is 3 I cap plus 1 j cap plus 4 k cap, and R bar is 5 I cap plus 7 j cap plus 1 k cap. Okay, what are these? These are the position vectors of point PQR. Sorry, that is, somewhere you have the origin. I have said this many times. Somewhere you will have the origin. From origin, when you join point P, you get P bar. From origin, when you join point Q, you get Q bar. And from origin, when you join point R, you get R bar. So here you have origin. This is vector P bar, Q bar, and R bar. P bar, Q bar, and R bar. You may not show these vectors. It is understood. Okay. You may not show these vectors. It is understood. So the next step here is, after finding P bar, Q bar, and R bar, that is position vector of these vertices, I will go for the displacement vectors, that is PQ bar. I will find out PQ bar and PR bar. Okay, I am going to find PQ bar and PR bar. See why I am finding these two vectors? Because angle P is included between these two vectors. So I will write PQ bar equals to Q bar minus P bar. So Q bar minus P bar, Q bar minus P bar. Okay, so here I get 3 I cap plus 2 j cap. I am subtracting P bar from Q bar plus 6 k cap. Then I will go for PR bar. PR bar is R bar minus P bar. So R bar minus P bar, I will get 5 I cap plus 8 j cap plus 3 k cap. So I got P bar and I got PQ bar and PR bar. I have to find angle P. Now students, by dot product of two vectors, you know PQ bar dot PR bar by definition is mod PQ bar mod PR bar and cos of angle between these two vectors. Cos of angle between these two vectors. Now, what is angle between these two vectors? It is P. So, into cos of P. So, this is what we get. So, what is cos P? Therefore, cos P will be equal to PQ bar dot PR bar upon mod of PQ bar into mod of PR bar. This is, I write this as equation number 1. Now what I'll do is I will find out whatever I need on RHS and then substitute to get cos of P. Once I get cos of P, I got the angle P. So first let us find out PQ bar dot PR bar. PQ bar dot PR bar will be this dot this. Now you know what is that. It is 3 into 5, 3 into 5 plus 2 into 8 plus 6 into 3, 6 into 3. Okay, or if you want to write it in detail, then you may write the vectors here. See here, so this is 3I cap plus 2J cap plus 6K cap dot, here you have 5I cap plus 8J cap plus 3K cap. So you will multiply and you get 3 into 5. You multiply the corresponding coefficients. That is, coefficient of I cap in this vector is multiplied to coefficient of I cap in this vector. Same for the coefficient of J cap. So 2 into 8, you have 2 into 8 plus 6 into 3. So you have, okay, so I made a mistake here. It is 3 into 5. So here it is 3. I'm sorry, 3 into 5 plus 2 into 8 plus 6 into 3. This is 15 plus 16 plus 18. So this will become 5 plus 6, 20. This is 15 plus 6, 21, 21, 31, 31, 39, 49. You get here 49. So this is PQ bar dot PR bar. Always remember that dot product gives you a scalar, that is a number. That is why the dot product is also known as scalar product. This is 2. Next I will go for, see, I got the numerator I have found. Now I will go for mod PQ bar and mod PR bar. So mod PQ bar is, mod of PQ bar is square root of PQ bar. Here it is 326. So 3 square plus 2 square plus 6 square plus 6 square, that is equal to square root of 9 plus 4 plus 36, that is square root of 49, that is equal to 7. So I got mod PQ bar as 7. This is number 3. Now PR bar, I will go for mod of PR bar. I found this, now I'll find out this mod of PR bar. This is PR bar is here. It is 5, 8 and 3, 5, 8 and 3. So I get here mod of PR bar equals to square root of 5 square plus 8 square plus 3 square. This is square root of 25 plus 64 plus 9. So this gets me, see here, this will get me 9 plus 25 is 34, 34, 38, 98. This is 98, which I can write it as 2 times of 49, that is equal to 7 root 2. I got mod of PR bar as 7 root 2, number 4. The next step I write as, I write here using using 2, 3 and 4 in 1, we get, what do you will get? You will get cos of p equals to, cos of p equals to, in the numerator you had got, in the numerator, see, it was pq bar dot pr bar, which is 49 you got. So here you write 49, and then in the denominator you have mod pq bar and mod pr bar, mod pq bar, mod pr bar. These two also you have found. This is 7 root 7 into 7 root 2. Now you know 7 sevens are 49. So next step you get 1 upon root 2. Cos of p is 1 upon root 2. So p equals to cos inverse of 1 by root 2. So p equals to 45 degrees, or you can write pi by 4. This is the angle. This is the angle between the two vectors. That is, this is angle P. We have found angle P. Now the next question is number 8. If P cap, Q cap and R cap are unit vectors, find first P cap dot Q cap, second P cap dot R cap from the following figure. This is the figure that we have to follow. The figure is given in the question. So we have to solve for these two. We have to solve for these two referring to the given figure. The question is based on this figure. Very important. Okay, so we will follow the figure and answer the question. What we need to notice here is they have clearly said that these three vectors, which three vectors? P cap, Q cap and R cap. P cap, Q cap and R cap, they are unit vectors. Now students, you know, if they are unit vectors, their magnitude will be 1. Okay, so here I start answering. I will write here mod of P cap equals to mod of Q cap equals to mod of R cap equals to 1. Okay, as P cap, Q cap and R cap are unit vectors. They are unit vectors. Now here one more thing to be noted is we are given a triangle. The three sides of the triangle are these three unit vectors. Now students, you know, if in a triangle all the three sides have equal length, the triangle is an equilateral triangle. It is an equilateral triangle. So this triangle here is an equilateral triangle because the three sides are equal in length. Each one of them has length equal to 1. So it is an equilateral triangle. So what will happen? These angles, all the three angles will be equal to each other, and then each one of them will be equal to 60 degrees. Each one of them equals to 60 degrees. Okay. So the next step I write here is the above triangle is an equilateral triangle. Equilateral triangle. Therefore, the angles between each pair of unit vectors, is 60 degrees. That is, whichever two vectors you take, the angle between them will be equal to 60 degrees. So angle between P cap and Q cap, 60 degree. Angle between P cap and R cap, 60 degree. R cap and Q cap, 60 degree. So now I will start answering the question. The first one is P cap dot Q cap. I know by definition of dot product, P cap dot Q cap will be mod P cap into mod of Q cap into cos of angle between the two vectors, which is 60 degree. So I get here, I know these two magnitudes are equal to 1. So 1 multiplied by 1 multiplied by 1 by 2. Cos 60 degree is 1 by 2. So the final answer is 1 by 2. P cap dot Q cap is 1 by 2. Then I go for second. Very simple question it is, students. Very simple question. Then I have P cap dot R cap. Again, this is by definition mod P cap, mod R cap, and then cos of 60 degrees. So this is 1 into 1 into 1 by 2. So the final answer is 1 by 2 again. So we got the solution of this question also. Now the next question is number 9. Ninth question is, prove by vector method that the angle subtended on semicircle is a right angle. Now this is some theory which we have studied in school. Lower standards we have studied that angle subtended in a semicircle is a 90-degree angle. But we need to prove it here with the help of vector method. So for this, here I have drawn a diagram. So my answer will start from here. See, here I have a circle. The center of the circle, I have taken it as O, the origin, and the diameter I have taken as AB. So if it is a semicircle, then what I will do is I will remove the lower part of the circle. So here I have a semicircle. I remove the lower part of the circle. So now I have a semicircle here. What I have to prove? I have to prove that angle subtended on semicircle is a right angle. So I will take the angle subtended on semicircle. So see, this is the angle subtended on semicircle. Here we have the angle subtended on a semicircle. That is angle subtended by the diameter on any point on the circle. So I will call this point as, say, point, I call this point as C, which is on the circle. I have to prove that this angle is 90-degree angle. This is a 90-degree angle. So my solution will start as follows. I'll write here, referring to above figure, O is center of the circle. O is center of the circle. AB is diameter. AB is a diameter of circle. Okay. C is any point on the circle. Any point on the circle. Okay. What we have to prove, students, very clear. We have to prove that angle subtended on circle is a right angle. So I will write here to prove that. So I will write here to prove that angle ACB equals to 90 degree. Now see, students, to prove angle ACB is equal to 90 degree, that is to prove that vector AC bar dot vector CB bar or BC bar, whichever way you say, it's one and the same thing. AC bar dot BC bar, that is to prove that AC bar dot BC bar is equal to 0. As you know, students, if the dot product of two vectors comes out to be 0, then the two vectors are perpendicular to each other. Okay. So this is what I have to prove. This is my aim. If I could prove this, I have answered the question. So here I write, okay, students, O is the center, O is the origin. Now see the diagram. In the diagram, this vector OA bar is A bar. OA bar is vector OA bar is position vector of point A. It is position vector of point A. OA bar is position vector of point A with respect to O. So I can take that as A bar. I will write here OA bar is equal to A bar from the diagram. So if you want, you can. But we have already written it, so no need to write again. We have already written referring to the above figure. So OA bar is A bar. Next OB bar. OB bar is B bar. OB bar is equal to B bar. And then I have another vector which is OC bar. Look at this vector, OC bar. I have another vector which is OC bar. This vector, OC bar. Vector OC bar. And this vector is C bar. I will write here vector OC bar is equal to C bar. Now what is important here, students, that these three vectors have equal magnitude. Each one of them will have same magnitude. Why? Because they are the radius of the circle. So here I will write mod of A bar equals to mod of B bar equals to mod of C bar equals to radius of the circle. Radius of circle. Each one of them is equal to. The magnitude of each vector is nothing but the radius. Further, what I notice is, look at this A bar and B bar. These two vectors, A bar and B bar, they have same magnitude. They have equal magnitude, but they are in opposite direction. See, A bar is this way and B bar is in another way, opposite direction. So what I will say also A bar equals to minus B bar. A bar is equal to minus B bar. Okay, now after writing this, I will go for AC bar. See, I will find out AC bar and BC bar. So here I'll go for AC bar. AC bar is, you can see here, students, AC bar. What is AC bar? By the triangle law of vector addition, AC bar will be equal to, I will write here, AC bar is AO bar plus OC bar. This is by triangle law of vector addition in triangle AOC, in triangle AOC. I got AC bar. What is AC bar? AC bar is very simple, students. I hope you all are following it. See, AC bar. AC bar is, this vector is AO bar plus OC bar. Okay, A to O, O to C is same as A to C. Okay, then next you have, okay, I write this as 1. I write this as 1. The next you have is, you want BC bar. So you will write BC bar is equal to, see, I want BC bar. If you check this BC bar, then BC bar is BO bar plus OC bar. B to O, O to C is same as B to C. So this we will write it as BO bar Okay, I'll make one small addition before I go for, see here. What I will do is, in AC bar, now I will substitute what is AO bar. AO bar is, see here, students, OA bar was A bar. So AO bar will be negative A bar and this is C bar. So what I got here, I got AC bar as C bar minus A bar. Okay, C bar minus A. Now I'll go for BC bar. BC bar, as you know, BC bar we had written as BO bar plus OC bar. BO bar plus OC bar. This is BC. So here I have BO bar plus OC bar. Now BO bar, OB bar is B bar. So this is negative B bar plus C bar. So we have C bar minus B bar. This is BC bar. This is number 2. I have got these two. Now I'll go for their dot product. I want AC bar dot BC bar. So here I will write, therefore AC bar dot BC bar is, therefore AC bar dot BC bar is equal to, what is AC bar we obtained? C bar minus A bar. C bar minus A bar dot C bar minus B bar. This is now simple distribution of dot product over difference. So we will distribute this over C bar and then B bar. So here we get C bar minus A bar dot C bar minus C bar minus A bar dot B bar. Now distribution from right. Distribution from right. So here you will have C bar dot C bar minus A bar dot C bar minus C bar dot B bar plus A bar dot B bar. This gets me mod of C bar square, and here I get, here I will write, see, students, look at this. We have already written here A bar equals to minus B bar. You see this? A bar is minus B bar from the diagram. So I will use it here. A bar is minus B bar. So here where you have A bar, I write minus, and this will be minus B bar dot C bar. And this is minus C bar dot B bar. Once again, here A bar is minus B bar. So I will write minus B bar dot B bar. Okay. So what did I do, students? You need to note it here. What did I do here? See, for A bar, I wrote minus B bar, and here also for A bar, I wrote minus B bar. This is what I did. And how could I do it? Because we have already referred to the diagram and we had found it. So next step you have mod of C bar square plus B bar dot C bar minus, now here you have C bar dot B bar. You know C bar dot B bar is same as B bar dot C bar. Dot product is commutative. So C bar dot B bar can also be written as B bar dot C bar. I can write here B bar dot C bar. And this is minus mod of B bar square. So the next step that you get is the final step. See. First of all, these two will cancel. They are same and they are opposite in sign. So you have therefore AC bar dot BC bar is equal to, you have mod C bar square minus mod B bar square. And you know, students, mod C bar, mod B bar, both are equal because they are radius. So their squares will also be equal, and hence they are also going to cancel each other. They are also same. So this is equal to 0. So AC bar dot BC bar is 0. You write, therefore AC bar is perpendicular to BC bar. Therefore the angle subtended on semicircle is right angle. Hence proved. I hope you followed it. Go through this once again and write it. The next question, which is the last question of this video, it is if a line has direction ratios 4, minus 12, 18, then find its direction cosines. So in this question, the idea is we are given direction ratios of a line. What we are given? We are given the direction ratios of a line, and from the direction ratio, we have to find its direction cosine. Now, the method is very simple. I have already taught you this in the earlier videos. See here, I will write the DRS of line R 4, minus 12, 18. Now students, I notice that there is a common factor here 2. So I will divide throughout by 2. That is 2 minus 6, 9. Now you write 4 minus 12, 18, or you write 2 minus 6, 9. It means the same set of direction ratios because they are proportional numbers. See, these three numbers and these three numbers are proportional numbers. So though they seem to be different set of numbers, they mean the same direction ratios. Remember, they mean the same direction ratio. As a matter of fact, if I multiply 2 in these three numbers, and suppose I get 8, minus 24, and 36, even these three numbers mean the same direction. Okay, all proportional set of three numbers will mean the same direction ratio. Okay, so we have got 2 minus 6. I will write therefore the DCS of the line can be given as follows. What is the idea? The idea is very simple. See, the DRS I have the DRS as 2, minus 6, and 9. So the DCS will be very simple, students. It will be 2 divided by square root of 2 square plus minus 6 square plus 9 square, comma, minus 6 divided by square root of 2 square plus minus 6 square plus 9 square, comma, 9 divided by square root of 2 square plus minus 6 square plus 9 square. So you have understood what I did. I divide 2, I divide minus 6, and I divide 9. Each of these three numbers I divide by square root of sum of square of all these three numbers. So this is 2 upon square root of 121 minus 6 upon square root of 121. If you add them, you will get 121. See, 2 square is 4, minus 6 square is 36, and 9 square is 81. So when you add them, this is 1, and here you get 1. So this is 12. So 121 you are getting. So what is the sum of the squares inside the square root? It is 121. So you get square root of 121, and here you get 9 upon square root of 120. You know that square root of 121 is 11. So finally you got therefore the required DCS, that is direction cosines, are, what are they? They are 2 upon 11, minus 6 upon 11, and 9 upon 11. Now I would like to add something here. See students, if somebody writes here 2 upon plus or minus, plus or minus, plus or minus, So what it will be? It will be 2 upon plus minus 11 plus minus 11 plus minus 11. So even this is okay. This is also correct. What I want to tell you is, what I have done is I have taken only the positive square root. I divided only by the positive square root. If you divide by positive as well as negative square root, still it is okay. Still it is okay. Okay. So this is what the answer we are getting. If you divide by plus or minus, then see what will happen. Remember, this answer is also correct. But in case if you are dividing by plus minus, okay, here I have divided only by plus. See, not writing any sign is positive sign. We have divided by positive only. But suppose if I divide by negative also, so positive and negative both, if I divide by positive, negative both, then what will happen? Then you will have this way. That is, in the next step, you will write plus minus 2 by 11. You will write here, plus minus 2 upon 11. Then, see, this is minus, negative sign up, so plus minus will become minus plus. See, because of this negative sign, it is not, it is no more plus minus, it is minus plus. So it will become minus plus 6 upon 11 and plus minus 9 upon 11, plus minus 9 upon 11. Okay, so now you have two sets of DCS. Therefore DCS are 2 upon 11. See, first I will take the first set of numbers, so plus, minus and plus. So 2 upon 11, minus 6 upon 11 and 9 upon 11. Or now you will write the next set of numbers, minus 2 upon 11, plus 6 upon 11 and minus 9 upon 11. Okay, now why we are getting two sets of DCS? Please don't write them in bracket. Please don't write them in bracket, because if you write them in bracket, they will not be DCS, they will become the coordinates. So they are without the brackets. Further, why we are getting two sets of DCS? Because it's a line. Don't forget, it's a line. So if it is a line, it has direction both the ways. See, it is this, it is in this direction as well as in this. It is in both directions. So you can have two sets of DCS. Okay, but remember, if you are writing only positive, as I had done earlier, that is, we would write only 2 upon 11, minus 6 upon 11, 9 upon 11. That is, if we are getting only this, then also it is correct. I hope you have followed. I have solved all the problems. I have solved all the problems up to 5.3. Up to 5.3, I have solved all the problems, and this, all the problems up to 5.3, you will get up to lecture number, I suppose, 21. Up to 21, lecture number 21, you will get all the problems of 5.3.